Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. This is question 1462, course schedule 4. So basically you want to return a Boolean array for each query based on whether this is a prerequisite of this, and you're given this prerequisites matrix where this is the parent of this, which is the child. So it says here indicates that you must take course A first to take course B. So A is a prerequisite of B, meaning it must come before B in order for you to take B. So cool. So let's just go ahead and make a dictionary to reflect that. Default dict list, and let's go through each prerequisite pair, and let's just go ahead and append A to B, because in order to take B you have to satisfy A, right? Because we want to figure out here whether U is a prerequisite of this or not. Cool. So now let's go over each query, and we're going to ask if A is inside of DFS of D of B seen or set, right? Because we're going to explore this whole subtree. So basically we're just going to, let's say we have 3 and 3 is the parent, and you have 5, 4, 6. So we're going to go through each of these, explore 5's key, and let's say 5 has 7 and 8, and then 7, find 7's key. So basically find all of the entire subgraph of that number to see if A as a value is inside of the entire subgraph, right? So then we're going to go through 8's key and then 8's key's values. So we're just going to keep doing this until we cannot anymore, right? So just a standard DFS, think union find. So basically, let's go ahead and define that DFS function. So current and seen. Cool. So for C and current, so if we're looking at 3, if B is 3, then we're going to go through this and we're going to look through first, if C is not in seen, then we're going to add C, and then we can go ahead and explore C's neighbors as well, right? So for neighbor in D of C, right? D of C, because we already appended the key itself. So if that neighbor, now the neighbors, we're just going to keep exploring the keys until we cannot, right? So if neighbor is not in seen, then seen.add neighbor, and then we're going to run a DFS on that neighbor itself, right? So D of neighbor and seen. And then at the end of this whole tree hierarchy, we're just going to return that set, because that's going to include all of the graph's children that you could potentially get from 3, which in this case would be 5, 7, and 8, and then 7 is not in here, so 8 including 9 and 10, and then that's it, right? And then seen would have all those elements, 5, 4, 6, 7, 8, and 9, 10, right? So if it is in there, then we can just go ahead and say A is a prerequisite of B because it's in the subgraph of B, right? So append true, otherwise answer.append false, right? And then at the end, we can just return answer for evaluating each of these queries one by one from left to right, right? So A is this, B is this, right? So let's go ahead and run this. Okay, prerequisites. Okay, submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.